Welcome to your channel Dr.Caos. Today I'm going to explain you what is a linked list in data structure. I'm going to give you the definition and the working of it. So starting with the definition, obviously a linked list is basically a collection of nodes which contains the address of the next node. Now this may sound Chinese to you because obviously you don't understand any of these right now, but that's the reason I've loaded up over here an image. Now this image represents a linked list. Let me explain to you. Now this rectangular box, as you can plainly see, is repeated 3 times. So this thing is actually a node. Each rectangular thing is a node. There are 3 of them, that means there are 3 nodes. So as you can plainly see that a node is divided into 2 sections, one is data and another is the address. Now the data is as simple as it can be your element, it can be a character, it can be a number, whatever data you want to store basically. And that data, when leaving that data aside, you have got something called an address. Now the reason we have this pointer, it's a pointer that you should note it, is for linking purposes. Now if I had just this node and there would be this address pointer, this wouldn't be able to point to this. Now the reason is, let's say an array, okay? An array is a static representation because basically when you run the program it is already allocated the memory, so it gets allocated at compile time, okay? But in case of linked list, the memory to each node is allocated at the runtime. So it is possible that this node is on the address 5000 and this node is on the address 7000. So in order to know which node comes after which node, there is the need of linking, okay? If the link was broken, let's say, okay, there wouldn't be any link. So basically your list would end right over here and give you some sort of error, obviously because you have lost the rest of the data. Now there are thousands and thousands of applications of linked list. Even in operating system these days we use linked list. Some kind of representation is used on the back end of the coding. So it's really important to learn what is a linked list, okay? Now I would like to explain you what are the things that we're going to use when we code. So let me take a paintbrush over here, and I'm going to apologize in advance for the ridiculous drawing that I'm going to do on over here, because let's admit it, I'm not a good drawer, okay? So here we have a nodes, right? So this node would be also called as the start node, okay? Sorry for the handwriting, as I told you. So this would be the start node. The start node is basically the node which contains the addresses, which contains the base address or the starting address of the first node. So this is going to contain just the address of this node. Now you would ask, how it's going to link with all these nodes, because you only have this address, right? So as you can plainly see, the address is linked to this, so indirectly this pointer knows the address of this node, okay? So it's just all indirectly done. You will understand this when we code. This is going to be a little difficult to understand right now. Now since we have a start of the list, we should also have a termination to the list. Now a termination is not a pointer or anything really complex. As you can plainly see, just assign the last address of the last node as null, okay? Assign this to null and you will know that the list ends over here. Now I would like to get started with the coding. Yeah, I think so I've covered everything up, so I'm just gonna start with the coding. Sorry for that. Let's load over here. There you go. Now how do we start, and what are the things that you're going to need to understand right now? You should know what is a structure, okay, how to define one. You should know what is a pointer. Not too much in depth about pointer, a basic knowledge on pointer would just do fine, and that's basically it. That's basically it. Yeah, all you need to know is the structure and what is a pointer. The rest we'll learn as we go coding, okay? So I'm gonna do this in C++. It's basically the same in C, only a few things changes which I will point out during I write the code. So let's get started. Let's define something called a structure. Now why do we use a structure? Well, the main reason is because we are combining the data and the pointer together, and the only way to do it is using a structure. So let's just define a structure. So I'm going to use a type def. Explain you that in a minute why I have done that. Struct and give it a name. I'm going to name it list of node. List node. Inside that I'm going to define a data. Okay. As we saw over there, there was a data and an address. But since this is a singly linked list, we're going to name that address as next. Okay. You can name it anything. You can even name it address if you wish, but it would be much let's say intelligent to do naming it to the next one, because that is the main function, right? It's pointing to the next element. So just name it next, and just let's save it next. Okay, you can name it address if you wish, I don't care. So there you go. Type def struct list node, integer data, and a pointer which will point to the next node. Now the reason I've used type def over here, because I want to define a data type. Okay, this thing is used to define a data type. Okay, you're creating a type, not actually data type, but just a type. Okay, so whatever name that I give over here after the closing bracket is going to be my data type. Okay, so this is node, which is a new type that I just come to define. Okay, there you go, that is defined. Now let's say that I want to create the start pointer, right? That's the main thing that we want to do. So let's define a start pointer. Now we're going to use our type that we just created, pointer start. Okay, so the type which we just created, which contains a data and as well as a next pointer, and we have given it a name called as start. Okay, nothing very special in it, to which we're going to assign a null. Now I have assigned it null, so if the list is empty, it's going to stay as null. So the starting of the list is the ending of the list if there's no node in it, right? So that is why I've defined that over there. So now we can go starting with the creation of the list. So void create. So I'm going to do it in functions because it's going to be really simple to understand. Alright, void create is the name of my function. So let's get started. How to create one simple node. Okay, so first you're going to create something called a node, okay, and something called a temp. Okay, both of these are pointers. Again, without a pointer you're not going to be able to do this. So this node is going to be our node, our actual node. This thing over here is going to be that thing. Okay, so that node is the actual node, and the temp, I will explain you why I have taken the temp. Okay, so node. So what we can do with this node is allocate the memory to it. Okay, so we can do it with the new operator. This is an operator which is available in C++ only, which is used for allocating the memory at runtime. Okay, new and node, obviously because of the type node. So it's going to allocate 2 bytes for the integer and 4 bytes for the pointer. So it's going to be a total of 6 bytes would be allocated to the node. Now, as I told you before, this is dynamically allocated, so that is the main reason I've used new operator over here. In C, what you need to do is use the malloc function. Malloc size of and the type. Okay, it's really that simple. Now that we have the node memory allocated, what we need to do is basically point its next pointer. Okay, so node of next, okay, is equal to null. So basically, let me come back to the image over here. So this is your node, right? So node of next means this. Node of next is going to point to the null directly, because if there's no element in the front of it, it should be the end of the list. So it is really important that you do so, right? You have to point the next element of the node as null always. Okay, so whenever you create the node, you point the next to the null and then you continue. Alright, so now we're gonna ask the user for the data. So we're gonna say enter data. Nothing special in that. Okay, enter data, and I'm gonna save it in the variable data that we just created in the structure. So node of data. So now what we have done is the next is pointing to the null, and we have got a data inside the node, so the node is entirely created. Now as you can plainly see up over here, the start is still null, but we already have a node created, right? So in order to assign this node as the start, we need to, well, basically assign this node to the start, right? So what we're going to do is say if the start is equal to null, so we are checking if it is null, which in this case it is. What we want to do is assign the node to the start. So this node that we just created is going to be the starting node, okay? And that's basically it. Now we come to the temp pointer, which I'm going to cover up in the next tutorial to avoid complexity, okay? So it's going to just increase the amount of pressure on your brain because it's really difficult to understand it the first time. So there you go. So start is going to be equal to the node. Alright, this is all we're going to learn in this tutorial. So now I'm just going to run the program once. Okay, so it seems to be committed some kind of mistake. Alright, so I have incorrectly spelled structure over here, so it's going to be struct. And I also forgot to call the function in main, so obviously I want to call create in main, okay? Put the semicolon and I'm going to run it. As you can plainly see, it's asked first for a data. So we just enter 5, enter, it finishes the program. Obviously we haven't done anything with it, but it's basically how to create the list. Now in the next tutorial we'll learn how to create a lot of nodes and link them together, but for this much, for the first tutorial, I think this is enough. So I'm just going to recap everything. So we defined a structure which consists of a data and a pointer which points to the next element. And then we declared some pointer called a start, to which we assigned as null because that's going to be the start, and since there's no node in the front, that should be pointed to the end of the list. So this is really important, okay? If you don't declare this thing, okay, it's not going to change the world or anything like that. If you remove the null, obviously you have to declare start, but if you remove the null, if the list is empty, then it's not gonna do anything. So it's really important to assign it as null. That's the only reason I did it. But if you know that you're gonna put nodes in it, then the null is not really important. So just declare the start and declare it as globally because we wanna access it throughout the program, okay? So once that is declared and assigned to null, we come to the function called as create. In this function we declare a node to which we allocate the memory at runtime, okay? So whatever bytes are needed in order for this to operate are allocated at runtime to the node. Then the node's next pointer, which holds the address of the next node, which is directly assigned to null because if there's no node in the front, that should be the end of the list, okay, as I demonstrated to you before. Then we said to the user, well, enter the data you want to store in that node. So we entered 5, so that 5 was stored inside the node. And then we said if the start is equal to null, means the starting of the list, if it's null, which is this pointer over here, it should be assigned as the node. So the start pointer will hold the address of the first node in the list. That's the main purpose, as I showed you before in the picture that we saw. So I'm going to just bring up the picture one last time. So we entered the data over here as 5 and pointed this to null, so means this wasn't over there. So this is our list created with only single node, okay? So there was a data, there was an address which was pointing to nothing, obviously because I didn't want to increase the complexity of this program because it's going to be really simple to understand this way, okay? So we entered the data and we pointed to the next pointer to the null, okay? So that null says that this is the end of the list. There's no more nodes in the front, and that is basically it. In the next tutorial we'll learn how to create many nodes and link them together, which is really simple. If you understand this, you will understand that in a jiffy. And we will also learn how to display that list. And that's basically it. So this has been the channel Dr.Caos. I hope you like this video. Rate, comment, subscribe. Thank you very much.